So I guess people will still keep on walking in, but we'll start now. So the session today is exploring AWS. We're going to see a couple of demos. We're going to see the AWS dashboard specifically for IoT. And yeah, and then there are some projects that I've already put up. We're also going to go through them. So these are the, and in the end, we'll kind of see comparison between different development boards and different cloud providers. So those two are the two connecting parts. Right, so Amazon as a I'll start with basics of what's Amazon Web Services for those of you who don't know. So Amazon started as a company in 1992 or something around that, and they were an online bookstore, and they grew rapidly. And around 2002, their chief architect wrote a paper on how Amazon could restructure its internal infrastructure and make it available for public use, right? And that was the beginning of Amazon Web Services. And then that grew so much that now Amazon is 14 times bigger than its next 10 competitors combined, which is a huge thing, right? It's a monopoly because the 10 next competitors basically include Microsoft, Google. There are people like Rackspace, who started as a startup and now big. But Amazon had the lead, the advantage of starting out early, and they are now the biggest monopoly in the cloud and as a service, anything as a service infrastructure, right? So this is how the AWS IoT dashboard kind of looks. We are going to take a look at that in a bit. But yeah, so Amazon is the largest cloud service. It supports standards for Amazon AWS IoT supports standards which are targeted towards devices with a lot less power than your standard smartphones and web browsers and all of that, right? So it supports standards like MQTT. REST is also supported by low power devices, so it supports that. And the most important advantage of that is it works great with existing Amazon Web Services. Amazon AWS has in itself more than 50 services, right? Including some of the more famous ones like EC2, S3, DynamoDB, and stuff like that. So Amazon AWS IoT works very tightly with these services, so that if you already have an existing app or a website which is running in Amazon AWS and you now want to add Internet of Connected Devices to that, it's quite easy. Interestingly enough, Amazon also is in hardware, right? We've all used Kindles, and we've seen Amazon Echo and Fire TV and all of that. But apart from that, they've also bought a silicon firm. Right? So Annapurna Labs is a microelectronic company based out of Israel, which makes silicon, right? Silicon like Marvell, silicon like TI and stuff like that. And now Amazon has also bought that company. So it's an interesting thing. Amazon kind of owns everything from the silicon all the way up to the cloud, right? So that's an interesting way to look at it, because that gives them a unique advantage of, kind of seeing everything from all the points of view. Right, so this is Marvell's MW302. So this is the board that we're talking about. What it does is it's an ARM Cortex M4, right? It's got DSP and floating point support. It's got a bunch of GPIOs, I2C, SPI, ADCs, DACs, all of that. But what's its key feature is its software, right? So there are certain features which are very hard to find in other silicon chips. We are again going to take a look at comparison between different Wi-Fi development boards later. But right now we'll just take a look at this. So security, okay, so I'll go back. Security, so this board supports secure boot. Secure boot allows basically you to control what software runs on the flash, right? You need to have the right access keys, the right private key and the right public key to run software on the flash. So it keeps you, so as long as the private key is safe, it keeps you safe from people who want to run different code on your consumer appliance or something like that. It's got plenty of peripherals. One of the key peripherals that it has is the USB support. So it supports USB OTG, which is not found in a lot of microcontrollers. XIP means execute in place. So usually microcontrollers have RAM and they have flash, right? And you have to bring your code from flash to the RAM and then execute it. But what this chip supports is execute in place. So you can keep the code in the flash and execute it then and there, right? So this allows us to basically have as much of our code space that we want. So it has a 512 KB, which is more than most of RAM, but it can support 2 MB flash or 4 MB flash depending on your application size, right? If it's an audio and video application, then sometimes there are a lot more libraries and files involved. In that case, you can go for a 4 MB flash. But if it's a smaller application, then you can stick to 2 MB flash and it will work fine. And then it has already been used in a couple of consumer appliances. So one is Mattel's Hello Barbie, which is a Barbie doll which works kind of like Siri. So you can talk to her and then she talks back, and it's not just pre-recorded messages. It communicates with the server, parses what you said, creates appropriate input or output based on if it's a question or an answer, and then sends it back. And then you can kind of talk it. Whirlpool has their own set of smart washing machines and appliances which are using this, and there are quite a lot more. I don't want to spend more time on that.
When we talk about the security, means is private public keys already embedded on the chip, or keys we can input separately sometime later?
No, you have to do this during manufacturing, right? So this is part of the manufacturing process, and then once it goes to the it goes out in the field, you have to keep. If you send a new upgrade, let's say you want to change some part of the application key, that has to be signed using these keys. Right? You can't send it using different keys. And then the device will check based on whatever information it has, whether the new firmware that it has received is signed according to the same principles, the same key that is. If it is, then it will work, otherwise it won't.
And in case how that it is, our key is compromised now, we want to change it. Is it possible?
I think it is, right? We can't. If the key is compromised, I don't think we can do much.
No, if the symmetric key is compromised, there is no way because it's
yeah.
But there's a signing key as well, so you can have a private key at one end and just the public key.
Yeah. Okay, so what we're going to do is we're going to use MW302, which is Marvell's board, and we are going to take AWS IoT and then connect something using Wi-Fi to this cloud. So before that, this is not exactly visible. So this is so these are the different peripherals. This is the pin map for the board. Yeah. So on one side of the board, you have something like multiple UARTs, SSPs, right? I2Cs, general purpose timers, which you can use as PWM and stuff. On this side, we have ADC channels, again SSPs, we have wake-up timers and stuff like that. So all of this is I'll be linking the slide deck, and this has the link to the actual pin map on GitHub. So if you want to take a look at it later, you can still do it. Right. So the first thing that we're going to do is we are going to create a new thing. Then we are going to attach a policy, and then we are going to connect it to the physical device, right? By putting the keys on the device itself. So thing is a terminology used by Amazon. It represents a particular device, right? Policies are attached by Amazon to each device, right? This allows me to take mass action. So let's say I have 10 different kind of consumer appliances, and I want to do an action on a particular type of that, one out of those 10. So all of those 10 devices will be attached to a particular policy type. And when I make changes to that particular policy type, it will kind of get reflected everywhere. So that is, plus, it also has other credentials like who has access to this particular device and all of those things. So that basically is part of the policy. Yeah, so let's create a resource. So is this visible enough? Yeah, so this is how your Amazon AWS console will look like. When you go there, you can create a resource. So now there are 4 kinds of things that we can create. So first is a thing, second is a rule, then it's a certificate, and then it's a policy. I'll explain what's a rule we've seen what's a policy, and certificate is the one that allows us to communicate, right? It will create a private certificate, public certificate, and a certificate, a public key, and a private key. Right. So first of all, we are going to create a thing, right? Let's call it. I'm not sure. Okay, so let's call it AWS IoT. I can add static attributes to it. So let's say this particular is located at a particular latitude and a particular longitude, right? Now this is not something that we will necessarily take from the device itself. If it has a GPS module, yes, we'll take that information from there. Or if you have something static variables like naming the name of the device or other such things, which are not going to change that often, you can set that here. So now I set the name of the device and I've set some random variables.
These attributes are programmable and
yes, you can change them whenever you want.
And it is going to this your device.
No, it's not going to go through our device. Those are again some different key value pairs. We'll come to that in a bit. No. So this is something on your application code. Yeah, this is some identifier. So this is related to your application. This is nothing related to the AWS IoT, right? So then I press create. Now it will have created this thing here, and you can see that it has a REST API endpoint, an MQTT topic, no state. State is basically it's updates, right? So if I have updated the device 5 times, then it will show 5. Attributes are the ones that we set, and the link certificates. I haven't linked any certificates yet. Once we link that, it will show up there, right? So next thing that I'm going to do is here there is something known as connect a device. Now we have created something in Amazon. Now what we want to do is we have to get it, find a way to link this using any Wi-Fi, any internet connection in the world, and make it talk to this particular device. So what I'm going to do is I'm going to say connect a device, and in that case, it opened up this menu, and I have to kind of pick what platform I'm using. So I'll be using embedded C, and the next thing it says that first you will need to create and download security credentials, etc., etc. And it will create a certificate and policy, and then I can download these 3 things. Right? We don't need the public key. We are only going to need the private key and certificate that we have to put on the device. Right?
Yes.
Yeah.
This Marvell code does have a Wi-Fi.
Yeah. Okay. I'm sorry if I didn't explain that correctly, but yeah, this is a microcontroller plus Wi-Fi SOC. Right? So it's all on one silicon, and that's all it requires. So, yeah.
This device has to be compatible with AWS IoT.
Yes. So what you need to support is, there are some. So Amazon basically has created a standard SDK, written in C, written in JavaScript, and all of that. And you can download that and then make it work on your board. Right? It has some requirements. So, for example, it requires TLS and all of that. It requires MQTT. Right? So it has certain restrictions. Because of the library size, you can't run it on an 8-bit microcontroller. So because of that, it won't be able to run on Arduino Uno, right? Because it doesn't have enough space, very honestly. Yeah, so you can run it on basically any 32-bit microcontroller platform. It just has to support those things.
So this private key is the Amazon key, the API key or like.
No, that's not the same one. That's the key that identifies me as a user. This identifies a device. Again, that is linked to me as a user, but you can't use this private key and public key to access other Amazon services from my account. So if I give this key to you, you will only be able to access the device. You won't be able to access everything else.
This key will all the rest calls.
Yes. Any communication that happens between AWS IoT and my device happens using these keys.
Okay. And the certificate is for FTPS communication?
We kind of need it for MQTT too.
But every device will have its own different keys.
Yeah.
Even if it is same model.
Yeah. So if I want to do another demo, I'll have to again generate keys and put that on this. because that uniquely identifies your device.
How it plays with commercial point of view means if a large millions of devices in the market.
Right.
So every time we have to download and embed that key in that device, then float in the market, then connect to the IoT.
Yeah, so this is part of your manufacturing process. Right now, we clicked and downloaded the keys, but you can use API calls that connect to AWS IoT, and then you can say ask it to connect, create 1,000 things or 1,000,000 things, download the keys for all of that, and then that will become part of the manufacturing process. So when you're flashing the device with your application code, you'll kind of flash it up. But for development purposes, it is easy to do that at runtime. That's why we are doing this. Otherwise, that becomes part of whatever happens on your assembly line. Okay, so I'm going to open these keys. Yes. Yeah. So this is how these keys look like, and this will allow you to basically connect. Right. I'm going to say confirm and start connecting. Then it will kind of show me that I need to create all of this, but that's only if I'm using the official SDK. We are using Marvell's flavor of that SDK. Right. So this is the SDK that we are using to create. So this is again an open source SDK from Marvell, which has all the required libraries and stuff for connecting to AWS IoT using this board, right? So I already have it downloaded here, right? And what I'm going to do is I'm going to first check whether my device is connected, and it's connected. On Mac, there are some steps that you have to follow so that you can connect the device using USB. That's an issue with the libUSB drivers on Macintosh. That's why I have to run a script every time I have to connect a board to Mac. That problem doesn't happen on Linux or Windows. Right? Now, if I go to this.
What you just did in this.
Yeah, okay. So what I did was I ran the script which unloads and loads the device driver for FTDI. Right?
Given by you or given by
No, these are the text commands. All of this is part of the Mac OS X. Right? I'm just running that in a particular order so that it will unload and reload the drivers so that it is properly visible in my USB device drivers. Right? So that allows me to kind of connect to serial. So this is only a Macintosh issue, and it is documented on the wiki page. So if you're setting up your device for Marvell MW302, all of the steps are there. So if you want to do Mac development host setup, you'll see that this is the part that we did right now, fix driver. So all of this is there on the wiki, and these are kind of installation steps. So I'm kind of skipping them right now, but you can go back to the wiki and find more information about it. Right. So the next thing that we are going to do is we are going to connect to this board that I have. Yeah. So it's 14141B. Right. Now I've connected the device. The next thing that we are going to do is this is if you go to the GitHub page and if you go to the releases section, you'll find out this blob. This blob basically consists of the application code, the Wi-Fi firmware, the bootloader, and the FTFS. And all of this is required. That's part of the standard application code which ships with the default board. What I'm going to do is I'm going to upload that, because right now I have some other things that I was working on it. There. So now it is in the process of flashing the device.
You are using Python.
Yeah, so the script to upload the device, upload the upload the binary to the flash on the board is written in Python, so that it is cross-compatible and it works on Windows, Linux, Mac, and all of that. We earlier had a Bash version of that, but it doesn't work well on Windows. You need to install a lot of other things to make that. Okay, so resetting flash to factory settings done. The next thing that I'm going to do is I'm going to reset the board, and if you see, it start. Okay, I don't know if this is visible. Is this visible enough? Yeah. So it started a micro AP called AWS micro AP AWS Starter FTC2. Right. Okay. Now, right. So the next thing that we're going to do is we are going to connect it to this particular micro AP. So it started an access point. The board is now acting kind of like a router, right? It is broadcasting some SSID. It has some password, and now what we're going to do is we're going to connect to it.